First of all, I welcome all the students and the participants who are attending this live lecture. See, today in this live lecture we shall discuss the operators D and del. The operators D and del. See this. These are the two new operators. Generally, D is denoted by the difference operator. D is denoted by the difference operator. So, एक मिनट स्टूडेंट आणखी आले नाहीत का रे ऑनलाइन. हाँ, so we shall discuss the difference operator. मुस्कान सेक्स, नेहा शिवनगे स्टूडेंट आणखी ऑनलाइन नहीं आले. जानवी डगे. Now, in this today's lecture, we shall discuss this. Up till we have studied, we know that the differences, operators, interpolation and equal intervals. In that first part, we have studied introduction, differences, factorial notations, forward operator, forward shift operator, backward shift operator, difference operator, delta, delta square, higher power of delta. And in the last lecture, we have seen some important examples based on the difference or delta. Some important examples based on the delta which we have studied in the last lecture. Now today we shall discuss the next part, that is operators D and del. We have to discuss the operator D and del. यहाँ पे हमें D and del operator के बारे में discuss करना है. So we shall revise this. Delta operator means forward differences, its second difference, delta 0 of f of a is equals to 1, k is equals to difference of constant is always 0. We have seen this. This is the factorial notation. X raised to r factorial means x into x minus h into x minus 2h. In this way, we have seen lot of formulae, number of formulas which we have discussed. This is the shift operator E. E is equals to 1 plus delta. This is the relation between the identity operator and difference operator. You know that. Now next we have seen some properties. Now we shall discuss the operator D. Then we shall discuss the operator del. Okay. So we can write the operator capital D. The operator capital D. This is the capital D. D stand for, generally here the operator D is standing for the derivative. Now we have to express the relation between D and E, D and delta, but you note that the operator D stand for derivative. See this, we know that the operator D, the operator D is used to express the derivative of y is equals to f of x. See this, such that dy by dx which is equals to f dash of x, then the difference operator D, D is a derivative operator which is denoted by D of the operator D is used to denote the derivative, that is dy by dx means dy which is equals to suppose f dash of x. dy means f dash of x, derivative of y. So d means d by dx, d2 means d2 by dx, dot dot dot, dn means dn by dx raised to n. So that is dy means dy by dx, d2y means d2y by dx square, dot dot dot, dny means, which is denoted by dny by dx raised to n. See this is the simple idea of the operator d. D means the derivative. D means the derivative. See this. आता डेरिव्हेटिव्ह विथ रिस्पेक्ट टू एक्स म्हटलं की इथं वाय एक्स असं पण लिहितात ना, वाय एक्स, डी वाय एक्स, डेरिव्हेटिव्ह ऑफ वाय विथ रिस्पेक्ट टू एक्स. So this can be written as operator D. Okay, now we have to form the relation between operator D. Okay, so we can write dy x means derivative of y with respect to x, d2yx means derivative of y with respect to x, dny means derivative of y with respect to x. Means main the operator D stand for derivative. D stand for derivative. Say this. Okay, now we have to prove the relation between, prove that E is equals to, second आता एक relation है, this is the operator D. Okay, now second operator del, किंवा याच्यावरचा एक प्रॉब्लेम घेऊ आपण. prove that E is equals to e raised to hd. Prove that E is equals to e raised to hd. Okay, now prove. We know that the Taylor's series is given by, here in the B.Sc. first year you know that there is a Taylor series. Can you tell me what is the form of a Taylor series in the form of a derivative? We can write f of x plus h, which is equals to f of x plus h into f dash of x. See this, you have seen the Taylor series in B.Sc. first year. So f of x plus h can be written as f of x plus h into f dash of h plus h square divided by 2 factorial f double dash of x plus h cube upon 3 factorial f triple dash of x plus dot 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 plus h raised to n divided by n factorial, that is fn of x. This is the Taylor series which we have studied in the B.Sc. first year, that is f of x plus h can be written as f of x plus h into f dash of x plus h into h square divided by 2 factorial. In this way we can write this. You know that this derivative notation can be written as f of x plus h, means it is also known as a y of x plus h. This is also called as a yx. This is also called as h into dyx. Derivative f dash of x means, see this, f dash of x means dy, or with respect to x means dyx, there is no problem. So plus h square upon 2 factorial f double dash of x. How to write this f double dash of x? F double dash of x means d2yx plus f triple dash of x h cube divided by 3 factorial d cube yx, derivative of y with respect to x. Here notation this is the notation in the form of d. Derivative can be expressed in the form of d because we have to write the relation between E and delta. You know the relation between E and delta, you know the expansion of e raised to x. तुम्हाला expansion माहित आहे का? काय असतं? See this, you can write the expansion. One minute, we shall discuss this. Now see here, see this, you can write the expansion. Now dot dot dot, last term काय तरी सांगा student. Now h raised to n divided by n factorial d raised to n yn. Now see this, on the left side we can write e of x plus h. Sorry, f of x plus h or y of x plus h. F of x plus h, you know that the shift operator e. Suppose this is 1, f of x plus h means we can write e of f of x or e of y of x. We can write e of y of x is equals to y of x. You can take this y of x commons also because the overall function is same. So 1 plus hd plus h square upon 2 factorial into d square plus h cube upon 3 factorial into d cube plus dot 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 h raised to n divided by n factorial d raised to n of yx. See this, here वाटलं तर इथं since म्हणून लिहा e of f of x is equals to e of f of x is equals to f of x plus h, or we can write e of yx is equals to yx plus h. This is the same process, no problem. This is actually the same process you can express in terms of y, in terms of x. This is a given that this is a e of y of x plus h means e of yx, or f of x plus h means we can write e of x plus e of f of x. This is the process for showing the function. Okay, so we can write this as e of yx equals to 1 plus hd plus hd bracket square divided by 2 factorial plus hd bracket cube divided by 3 factorial plus dot 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 plus hd bracket raised to n divided by n factorial of y of x. बराबर है करे students? Now this is a formula for, you know that the expansion formula for e raised to x. What is the expansion formula for e raised to x? We know that we can write e raised to x as, can you tell me what is the expansion of e raised to x? 1 plus x plus x square divided by 2 factorial plus x cube divided by 3 factorial plus dot 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 plus x raised to n divided by n factorial. This is the expansion series of e raised to x. So if we consider x as HD, if we consider x as HD, then 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial plus dot 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 x raised to n divided by n factorial. If we consider this x, then this is the expansion series of e raised to x. So we can write e of yx, which is equals to expansion series of e raised to x. X means HD of yx, HD of yx. So yx is the same function. So it is also known as e of f of x equals to e raised to HD of f of x. Yx same. So we can say that e is equals to e raised to HD. Okay, and hence proved e is equals to e raised to HD. Students, now you tell me, there is also relation between e and delta. What is that relation between e and delta? Also, we know that, what we have to know? Also we know that e is equals to 1 plus delta. Suppose this is equation number 1, suppose this is equation number 2. Therefore, from 1 and 2, we can write e is equals to 1 plus delta, which is also equivalent to e raised to HD. E raised to HD. Okay, so we can write it in the different form relation. कसे विचार द्या? व्हेरी गुड जान्हवी, अंजली कांबळे, स्नेहा, श्रद्धा, मुस्कान शेख, मुस्कान व्हेरी गुड, आकाश नरवाडे, मेले, कल्याण, रोहिणी पिंगळे. ओके, नाउ वी शॅल डिस्कस दिस नेक्स्ट रिलेशन. आता यालाच आपण वेगवेगळ्या पद्धतीत लिहू शकतो. कसं लिहू शकतो? delta is equals to, also we can write in the form delta is equals to e raised to HD or 1 minus e raised to HD minus 1. This is also one relation. म्हणजे लक्षात ठेवा, तुम्हाला जर काही विचारलं तर तुम्हाला त्या पद्धतीमध्ये प्रूव्ह करता आलं पाहिजे. बट मेन रिलेशन इज दॅट e is equals to e raised to HD. The shift operator here, in this case e means shift operator, forward shift operator, and e raised to HD, here capital D is, the derivative operator. Here the capital D is a derivative operator. See this, capital D is a derivative operator. So this is a proof. Prove that e is equals to e raised to HD. This is the proof of the theorem. And D means the operator D means the derivative operator, which is denoted by this, in this way. Okay. So y यालाच असं सुद्धा लिहितात ना, yx means derivative with respect to x. dx whatever may be. Okay. Now we shall discuss the next operator, backward difference operator. We shall discuss the backward difference operator. आणि तो del न दाखवतात, लक्षात घ्या, which is denoted by del. Backward difference operator which is denoted by del, forward difference operator which is denoted by delta. Now how to define the del here? The operator del the operator del is called backward or ascending, backward or ascending difference, ascending operator, backward operator or ascending operator, or ascending, or ascending difference operator, and is defined as del of f of x, del of f of x, which is equals to f of x minus f of x minus h, f of x minus f of x minus h. Or also we can write del of f of x plus h, which can be written as f of x plus h minus f of x. म्हणजे दिलेल्या del of f of x means f of x plus h minus, del means backward difference, means we have to subtract backward function from this function, backward function from this function, then we will get the backward differences, backward difference of this. फरक याच्यात लक्षात ठेवा, ही टर्म इथं असते फर्स्टला असते, ही टर्म फर्स्टला असते आणि त्याच्यावरनं त्याच्या पाठीमागचा फंक्शन वजा करायचा. आता फॉरवर्ड डिफरन्स कसा असतो पहा, डेल्टा एफ ऑफ एक्स म्हटलं की एफ ऑफ एक्स प्लस एच मायनस एफ ऑफ एक्स, म्हणजे ही टर्म f of x, we have to subtract f of x from its forward function. f of x ला फॉरवर्ड फंक्शन मधनं सबट्रॅक्ट करावं लागतं. आणि del of f of x म्हटलं की f of x मधनं त्याच्या पाठीमागचा बॅकवर्ड फंक्शन सबट्रॅक्ट करावं लागतं, f of x minus h, means f of x is here. फरक लक्षात ठेवा, f of x डेल्टा मध्ये सेकंड पोझिशनला असतो, डेल्टा मध्ये सेकंड पोझिशनला असतो आणि डेल मध्ये फर्स्ट पोझिशनला असतो, फर्स्ट पोझिशनला f of x. सी दिस, नोट दॅट डेल्टा आणि डेल मध्ये फरक लक्षात ठेवा. मग आता याच्यावरनं डेल्टा 2 काढू शकतो. डेल्टा 2 f of x म्हटलं की डेल्टा f of x, that means delta f of x, त्याचा फॉर्म्युला वापरा, f of x minus f of x minus h. Again we can take the difference, delta f of x, del f of x, delta nahi sorry, del f of x minus del f of x minus h. Then we can write this as f of x minus f of x minus h according to the definition of the backward difference. Also del f of x minus h can be written as f of x minus h minus f of x minus 2h. So we can write f of x minus 2 times of f of x minus h minus plus f of x minus 2h. This is the value of del 2 f of x. See this, second difference operator. डेल आणि डेल्टा मध्ये फरक काय माहिती आहे का, डेल्टा मध्ये फॉरवर्ड ऑपरेशन मधून दिलेल्या फंक्शनला वजा करा. मीन सपोज फॉर एक्झाम्पल For example, here if h is equals to 1, then del f of 10 can be written as f of 10 minus f of 9. Second, del f of suppose 5 can be written as f of 5 minus f of 4. फरक लक्षात येतं का रे? डेल मध्ये आणि डेल्टा मध्ये हे दोन झाले डेलचे. हा जर डेल्टा साठी असेल तर डेल्टा f of 10 म्हटलं की f of 11 minus f of 10. This is the delta, this is the del. मग del f of 10 means f of 10 minus f of 9. This is the value of del. डेल म्हणजे बॅकवर्ड डिफरन्स, दिलेल्या फंक्शन मधून f of 10 मधून त्याच्या पाठीमागचा फंक्शन वजा करायचा म्हणजे बॅकवर्ड डिफरन्स. आणि f of डेल्टा f of 10 मीन्स f of 10 ला त्याच्या फॉरवर्ड फंक्शन मधून वजा करायचं, पुढच्या फंक्शन मधून वजा करायचं. दिस इज द प्रोसेस ऑफ del and delta. This is the difference between delta. So we can write delta is equal delta f of 5 म्हटलं, डेल्टा f of 5 म्हटलं की f of 6 minus f of 5. So note that, see this, note that if interval of differentiating h number 1, delta f of x, the main formula we can write in the a, we can write in the form of a. suppose delta f of a म्हटलं की f of a plus h minus f of a. In that case, a is in the delta, a is at second position, which is subtracted. F of a means which is subtracted from its forward term. But in del f of a, f of a minus f of a minus h means this is del मध्ये हा सुरुवातीला असतो. del f of a means f of a मधून a minus f of a minus h वजा कर. फरक लक्षात ठेवा, दोन्ही मध्ये काय फरक असतो. f of a यामध्ये डेल्टा मध्ये f of a सेकंड पोझिशनला असतं, डेल मध्ये f of a फर्स्ट पोझिशनला असतं. सेम ॲज f of x, डेल्टा मध्ये f of x सेकंड पोझिशनला असतो, डेल मध्ये f of a फर्स्ट पोझिशनला असतो. डेल मध्ये दिलेल्या फंक्शन मधून पाठीमागचा फंक्शन वजा करा आणि डेल्टा मध्ये दिलेल्या फंक्शनला त्याच्या फॉरवर्ड फंक्शन मधून वजा करा. फरक लक्षात आला का रे डेल आणि डेल्टाचा? ओके, डेल आणि डेल्टाचा फरक लक्षात आला का? सो वी कॅन राईट. मग आता रिलेशन लिहायचेत आपल्याला डेल्टा डेल एच डी. तर आपण प्रूव्ह करू. प्रूव्ह दॅट. Next we have to prove important relation. Number 1, prove that del is equals to 1 minus e inverse or e raised to minus 1. del म्हटलं की लक्षात ठेवा, prove that हा प्रत्येक टर्म तुम्हाला समजली पाहिजे. प्रत्येक टर्म काय फरक आहे, डेल्टा आणि डेल मध्ये कसा फरक असतो, कशी डिफरन्स असते, वजाबाकीचा असतो. डेल्टा अँड डेल आर बोथ द डिफरन्स ऑपरेटर, both are difference operator, but delta is called forward difference operator. That means we have to subtract given function from its forward function. Del is also difference operator, but in del we have to subtract backward function from the given function. This is the main difference. Okay, so we can write this, prove that this is the relation. As like already we have proved, E is equals to 1 plus delta. In this way, we have to prove del E is equals to 1 minus E. Proof. Let y is equals to f of x be a function and h be the interval of differencing So we have, what is the formula? Shift operator E inverse, I म्हणजे इथं 1 सुद्धा येतो. We have, tell me student सांगा रे काय फॉर्म्युला? E inverse of f of x, or we can write f of a, no problem. We can write, सांगा रे काय येतो? We have seen this E inverse of f of x, or backward shift operator. This is called as a backward shift operator. E means forward shift operator. E inverse means backward shift operator, which is given by f of x minus h. Also, and I of f of x, which is also denoted by 1 of f of x, which is called as f of x. This operator is called identity operator. This operator is called as a backward shift operator. Also, del of f of x can be written as what is the formula? F of x minus f of x minus h. See this, but del of f of x, which is equals to f of x minus, see this, f of x minus h means from equation 1 we can write E inverse of f of x. E inverse of f of x. बराबर है क्या स्टूडेंट्स? यू हैव टू राइट E इनवर्स ऑफ f of x. अभी देखो मैं कॉमन निकाल सकता हूं राइट साइड को. सो डेल ऑफ f of x equals to, we shall take a common, then we get the identity operator or 1 minus E inverse of f of x. Now by comparing the operators, we can write I also here. 1 च्या जागी I सुद्धा लिहू शकता. That is identity operator. There is no problem. So by comparing the operators, how we can write, students? We can write, हाँ तो ऑपरेटर कंप्लीट करा. डेल इज इक्वल्स टू 1 माइनस ई इनवर्स. and hence proved. आता यालाच आपण वेगवेगळ्या पद्धतीने लिहू शकतो. E इनवर्स इज इक्वल्स टू 1 मायनस डेल असं पण लिहिता येतं, काही अडचण नाही आहे. सो यू कॅन राईट इन द डिफरंट वेज. लक्षात आलं का रे तुम्हाला? Okay, so we can write in this way. हे प्रूफ समजलं का? परत एकदा पहा, इम्पॉर्टंट आहे. let y is equals to f of x be a function and h is the interval of differentiating, then we have, according to the backward shift operator, E inverse is equals to f of x is equals E inverse of f of x is equals to f of x minus h I into f of a. This is the identity operator. That is the identity operator. Identity operator I into f of a, I of f of a or 1 into f of a, which is equals to f of a. Now we know that by the definition of the backward shift operator, del f of a is equals to f of del f of x is equals to f of x minus f of x minus h. So del f of x is equals to f of x minus E inverse of f of x. So take out the common f of x, then we get the result. ओके, अशा पद्धतीने हा रिझल्ट तुम्हाला होतो, म्हणजे समजला पाहिजे. ओके, काय अडचण तर नाही ना स्टुडंट्स? ओके, मग आता काही नोट आहेत, त्या नोट प्रमाणे तुम्ही लिहू शकता. हां, सी दिस note. I shall write the important note. Note. First, the operator D, which is denoted by d by dx, or dyx means dy by dx, means the operator D is denoted by the operator D is denoted by derivative operator. Second, delta, we can write del is equals to del of f of x is equals to f of x minus f of x minus h. Third, I also write delta f of x is equals to f of x plus h minus f of x. फरक लक्षात येण्यासाठी. 4, E is equals to e raised to minus hd, sorry, E is equals to 1 plus delta, which is given by e raised to hd, means E is equals to e raised to hd. फिफ्थ, आणखी एक रिलेशन प्रूव्ह केलंय, del is equals to 1 minus e raised to 1. आत्ताच प्रूव्ह केलं पहा, del is equals to 1 minus e raised to 1. So 6 we can write e raised to minus, आता इथं e is equals to e raised to hd, मग याला सुद्धा लिहिता येतं E inverse is equals to e raised to minus hd, but E inverse means 1 minus del, so we can write this as a 7. E inverse म्हणजेच 1 minus del, so we can write e raised to minus hd, which is equals to 1 minus del, or del is equals to, we can write also del is equals to 1 minus e raised to minus hd. Same आहे, e is equals to e raised to hd, then E inverse is equals to e raised to minus hd. This is the same operator, no problem, we can write this. Now okay, in this way we can write. आता याला लॉग मध्ये सुद्धा लिहिता येतं. लॉगचा ऑपरेटर आहे पहा, लॉग मध्ये कसं लिहिता येईल, 1 प्लस डेल्टा इज इक्वल्स टू ई रेस टू एच डी, दोन्ही साईडचं लॉग घ्या, एच डी इज इक्वल्स टू लॉग ऑफ 1 प्लस डेल्टा, HD is equals to log of 1 plus delta. So we can write HD is equals to 7वा 8वा HD is equals to log of 1 plus delta. See this from 4. दोन्ही साइडचं लॉग घ्या, ही सोडून द्या. E raised to x, you know that. It's like this formula. E raised to f of x is equals to जर c असेल तर f of x is equals to log c. We can write this. So 1 plus delta is equals to e raised to hd. So hd is equals to log of 1 plus delta. 9 नंबरचा फॉर्म्युला सेम असाच लिहिता येतो मायनस साठी. पहा मायनस साठी. So we can write in the form of a minus hd is equals to, so we can write e raised to minus hd 1 minus e inverse. याला असं सुद्धा लिहिता येत ना, 1 minus e inverse. Okay, now hd is equals to also hd is equals to minus log of 1 minus del, which is also given by del, plus del square divided by 2 plus del cube divided by 3 plus dot dot dot. In this way we can write the difference operator 10 okay, no problem, we have solved this. तर हे ऑपरेटर तुम्ही लक्षात ठेवा, एवढे ऑपरेटर लक्षात ठेवा. काही अडचण आहे का याच्यामध्ये? हे दोन रिझल्ट खूप महत्त्वाचे आहेत. प्रूव्ह दॅट डेल इज इक्वल्स टू 1 मायनस ई इनवर्स, अँड सेकंड प्रूव्ह दॅट E is equals to e raised to hd. E is equals to e raised to hd. So by using these two relation we can write, this is the second relation, prove that. By using these two relations we can prove, we can write these property. D means the derivative operator, del means backward difference operator, delta means forward operator, E means forward shift operator, delta means forward difference operator, E means forward shift operator, E inverse means backward shift operator. Okay, in this way we can write. Okay, काय अडचण आहे का रे ऋतुजा, कृष्णा, शुभम? शुभम नाही वाटतं, शुभम गेला का रे? प्रेझेंटी टाकून शुभम गेला का? शुभम आहे का रे? तर हे सर्व रूल्स लक्षात ठेवा. आता याची काही गरज नाही आहे, मी रिमूव्ह करतो याला, फक्त फॉर्म्युला तुम्हाला सांगितला होता. यू शॅल राईट दिस ऑल दिस टर्म्स यू हॅव टू नो. हे तुम्ही सर्व लक्षात ठेवा. नाउ वी शॅल स्टॉप हिअर. काय अडचण आहे का?